In fundamental groups, we are virtually looking at by anatomy simple X. We are virtually looking at a topological space, which we normally denote as X. Okay, that is one. Secondly, we are also concerned about what we call loops. Okay, about a fixed point. Some call it base point. Okay, normally represented X naught or just X simply. This is of concern to us because the study of fundamental groups is only just a study of loops, which actually form a group up to homotopy. Okay, so we are also concerned about homotopy of groups. So these things are very important for us to understand if we want to understand what we call fundamental groups. And these groups are actually evolve out of our curiosity in studying the structure of spaces, topological space. We feel that if we now have a topological space, yes, with abstract structures we may not be aware of, we now try to see is there any way we can link these to groups because we know the structures of groups. Okay. So if we can link this, we want to divide it into groups, isn't it? Then we can, by studying these groups, we are like studying this. But we know our groups, especially binary groups, we know their structures. So that's what we are trying to do, and then we realize that we have to now introduce what we call maps on this structure that will help us to identify certain like holes and say how many holes. And we can only do that if we have this idea. What is loop? What is homotopy? And so on and so forth. Or can we contract this to a trivial group? And then we now come to now, because of this, we now come to also ask ourselves, are these group free groups? Are they free? Which means the loops can be from any point. I can take a point here, make a loops. I can decide to take another one here. Or are they not free group? If they are not free, that means there must be a point of reference, maybe X naught, which you call base point. And we say that it is only, you can only construct loop from this point. Any other loop which is not from this is not, and so on and so forth. Okay? And we can also ask ourselves, is this group abelian? Then because with are abelian, we can translate homotopy groups into homology groups. Homology groups require that all groups must be abelian. Is it clear? It's of course it's not so for homotopy groups. But let us understand the underlying concept. What is a pointed space? Definition. Pointed space. A topological space X is called point. If that this is distinguish, okay, point X naught in X, okay, okay, and then so if it has a distinguished point like this, which is the center of this point, then this point is called the best point. Best point. Okay, which serves as the best point for loops in X. All loops have to originate from. Then we'll say that, for example, if you have a sphere and S1 or a circle, well, you have to identify a point X naught. So that all the loops they are going to do have to start from X naught. Then when a loop comes back to it, you say it is a complete loop. If it stops halfway, you say this is half, and so on and so forth. Okay. Or even S2. Okay. Or even S2. You must have a point. S2. And so on, cycle. So, analysis or whatever. Analysis. And so on.
We call it initial point.
We call it base point. Because for loops, we find out that initial point and final point are the same. That's why we prefer to call it base point. Yeah, so that maybe that discussion brings another important thing. What is loop?